Guys, I'm Carter. Today I will be doing a presentation on nitrogen dioxide. Nitrogen dioxide's chemical formula is NO2. It has 23 protons, 7 of which come from the nitrogen molecule, and the other 16 come from the 2 oxygen molecules, 8 in each. Enjoy. Now we'll be looking at electron configuration. To figure out electron configuration, you have to find the most recent noble gas that occurs on the periodic table. When looking at nitrogen, this noble gas happens to be helium. From there on, you cycle through your S's, D's, and P's, but in this case, we only have to use S's and P's. When dealing with nitrogen and oxygen, we don't have to worry about any of the D's, so the only thing we'll have to worry about are the S's and the P's. Let's start with nitrogen. So first, we have to find the most recent noble gas on the periodic table, which is helium. We'll put He in brackets, and immediately after, we'll put 2s2. The S's are lithium and beryllium. After that, since we don't have to deal with the D's, we'll start working on the P's. Nitrogen is the third element over in when we start dealing with the P's, so we'll have 2p3. When it comes to oxygen, again, we'll find the most recent noble gas, which is helium. We'll put He in brackets, and immediately after, 2s2. Once again, we'll skip the D's and start working on the P's. Oxygen is one more element over on the periodic table than nitrogen, so making it 2p4. This is a Lewis structure for nitrogen dioxide. It has a total of 17 valence electrons. Let's get started. On the left side, on the left oxygen molecule, it has 8 valence electrons in total. It has 3 pairs and 1 strand. Each strand is 2 valence electrons. On the right side, that oxygen molecule has 2 pairs and it's a double bond, giving it 4 more valence electrons. That leaves us with the nitrogen in the middle. So with all the bonds, it gives it a total of 6, but that would leave us with 1 remaining electron. So in this case, the nitrogen will not have a complete octet, making it kind of a weird Lewis structure. This is because the oxygen molecules need to be favored so they stay bonded to the nitrogen. And there's a double bond on the right side because that at least gives the nitrogen 7 valence electrons rather than 6. So according to the chart, the molecular geometry of nitrogen dioxide is bent. The bond angle is 120 degrees. The electron geometry is trigonal planar, and the nitrogen dioxide does not follow both of the polar rules, which makes it nonpolar. Here are a couple example reactions which include nitrogen dioxide. In the first example, you have 2 molecules of nitrogen oxide plus oxygen gas, which is 2 oxygen molecules. And that produces 2 molecules of nitrogen dioxide. On the bottom, you have hydrogen gas, which is 2 molecules of hydrogen, plus nitrogen dioxide. This produces water, a molecule of water, and 1 molecule of nitrogen oxide. Nitrogen dioxide is a hazardous chemical, so due to that fact, it isn't used for many things anymore, but in the past, it has been used to bleach some types of flour, and it is also produced a lot from combustion from certain types of fuels.